Hello, Y10. I'm just going to do a quick review of surface area and volume, and I'm going to include some similarity in there as well. The first question is on volume, and then the next I'm going to look at volume with some similarity. If you're happy with volume and you're happy with volume similarity, feel free to skip until it says to surface area. So let's get started with this question so we can try and hit our bronze learning outcome of calculating the volume of a solid. So I've got a prism, which is nice because we know how to calculate the volume of a prism. We know that we just need the area of the cross section multiplied by the depth. Okay, so I've actually written that over here. Now that doesn't hurt to write down, so you're showing the examiner exactly what you need to do and what you're going to do. So let's have a look at the area of the cross section. In this case, I've got a trapezium as my cross section. So I've actually drawn that again. Now you don't have to do that. But obviously just showing you understanding that you know what the cross section is, and it might make it a little bit easier to calculate the area once you've drawn it. They will try and put different numbers on there that might confuse you. So for example, in this case, I know that I didn't need the 10 centimeters. So once I calculate the area of that trapezium, I'm going to do the 8 plus 14 divided by 2, so that's the two parallel sides added together divided by 2, multiplied by the height, which in this case is 4, and I'll have 44 centimeters squared. Notice that I've got my centimeters squared on there. It's super important they're including those units. I've already written this down, but volume is area of cross section multiplied by depth. My depth is 10, so 44 multiplied by 10, 440 centimeters cubed. Job done, all good. I've hit my bronze target. So now let's have a look at another question. So I'm working with volume still. I've got shapes A and B are mathematically similar. If it takes 20 minutes to fill shape A with water, how long will it take to fill shape B? So as you can see here, shape A is actually the same shapes I've just looked at. I've also got part I and part II. That often means that the questions are related. Not always, but most of the time. So I know that I've just worked out that volume, and I've even said from part I we know that the volume is 440 centimeters cubed. Now what I'm going to do is work out a rate that it's being filled with water. So if I know that in 20 minutes it fills 440 centimeters cubed, in 1 minute if I divide by 20 it will fill 22 centimeters cubed. Now that's not the only way you could have done that. You could have worked out how long it takes to fill, say, 1 centimeter cubed or 10 centimeters cubed. However, in this case I decided to work it out for 1 minute because I'd rather divide 440 by 20 than 20 by 440 or by 44 or some other number. So in this case I found that the simplest way to do it. So now we can look at shape B. Now it tells us that they are mathematically similar, so that means that I've got a consistent scale factor. And as you can see, my corresponding lengths, I've got 14 and 21. They've only given me those, so I've got to use it. So to calculate my scale factor, I do 21 divided by 14, which is 1.5. So my length scale factor is 1.5, and really I should have written that down actually to show how I got that. In this case it's alright because I got it right, but if I'd have got that wrong, I've just lost the mark. Now we know to work out the volume then, I need to cube that. So 1.5 cubed, which is 3.375, that is my volume scale factor. Okay, VSF is a fine notation if you want to use that. That's absolutely fine. So I just need to multiply the volume of shape A by that new scale factor, my volume scale factor, to calculate the volume of shape B. So 1,485 centimeters cubed. Again, notice that I'm putting those units there. They are important. Okay, it shows that we know what we're talking about. However, I've not actually answered the question. It didn't ask me to calculate the volume of shape B, but I knew that I had to do that because we're talking about filling something with water. So we're looking at, say, the capacity of it, the volume of it. So I've got 1,485 divided by 22, because then I'm going to calculate how many minutes. It actually asks me for how long it wants it, so I do want to be in some sort of time measurement. So it says 67.5 minutes. I've used my calculator to work that out. Now what I've actually done is I've changed that. Okay, 67.5 minutes sounds a little bit daft to us, doesn't it? So that is 1 hour, 7 minutes and 30 seconds. Now just be careful that you don't put 1 hour, 7 minutes and 50 seconds. It didn't tell me that it wanted it in hours, minutes and seconds, so 67.5 minutes was a valid answer. That was still correct. I've just decided to change it. If you do that though, please make sure you are careful. Okay, that is something that you would check in those last few minutes of your exam when you're going through. So not only have I hit my bronze target now, I've started to hit gold actually, because I've just been able to apply similarity to volume. So now we're going to look at surface area. So it says find the surface area of the prism. Now I'm glad that it's a prism. Okay, I'd rather calculate the surface area of a prism than I would say a pyramid or something, although we can still do that. However, you've seen they've made it a little bit harder for us because actually they've made it a compound prism. So the first thing that I've done is I've counted the faces because that shows me how many areas that I should have in total by the end. So I've got 8 faces in this case. Now I'm going to start with the cross section because I've got 2 of those. Okay, and as you can see in this case it is a compound shape. That's probably going to be the hardest one to calculate. Now you can see I've drawn that, but mine looks slightly different to what's on there. Obviously it's not to scale, but I've also got 2 new measurements. Now that's because I've worked those out. Now I don't know if I need those yet, but automatically if I see a compound shape and I can calculate those missing lengths, I'm going to do so. It doesn't take very long at all to do, and actually when a surface area question is coming up, it probably is going to be used at some point. So to calculate this purple 5 centimeters, I've got 7 centimeters subtract 2 centimeters, hence 5 centimeters here. Then to calculate this red 5 centimeters, I've got my width of 9 centimeters, subtract this smaller width of 4 centimeters. So this measurement here must be 5 centimeters as well. Now that's pure coincidence that they're the same. So now I'm going to work out the area of my cross section. So I'm going to cut it up. Now there are other ways that you could have done this. I think this was the most straightforward. And it turns out that I did actually need to use one of those new measurements, so it's a good job that I did work those out. So I've cut it down here. I'm just actually going to draw that on for you just to show you where I cut it. So I cut it there, if you couldn't tell already. So I've got 28 for this part, centimetres squared, 10 centimetres squared for this part. Obviously I then need to add those together. Now I put at the top, I've got 2 lots of the cross section. I've got the front and I've got the back. So I've then multiplied that by 2. Okay. The next part that I'm going to look at is the base, because I think that's probably one of the easiest parts to work out as well. So the base is obviously just going to be a rectangle, 9 multiplied by 10, 90 centimeters squared. Again, notice that I'm putting my units there. Okay, I'm always including them. As long as you're including them on the answer, that's what's most important. But actually, if I can get in the habit of whenever I'm working out an area, I'm putting centimeters squared or units squared, whatever they may be, obviously that's best practice. I'm then going to work out the area of the back again, because I think that one is also quite easy to work out. Okay, so I've got 7 and 10. Notice that I've drawn them. Okay, that really helped me when working out the numbers. There's a lot of numbers involved in this question. So when I've drawn them, I've really thought about what is the dimension. So I haven't made a mistake. I haven't said it's 7 by 9. I've realised, yep, the height of that is 7 actually, and the width of it is 10. Okay, so 7 multiplied by 10, 70 centimeters squared. Again, using the correct units. What I then did, as you can see here, I've labelled them. Okay, I haven't put CBA, I actually put ABC before you all start. But that was just so that I could make it super clear what face I'm calculating. So A, I know is just straightforward rectangle, 2 by 10, 20 centimeters squared. And I'm going to look at B, and again, now you won't be using different colours obviously, but I've just shown where that dimensions come from. We looked at that earlier on. Okay, so it was 5 by 10 because I know that this bit here is 5. Okay, and I've used the red 5 because it relates to this part here on the cross section. So 5 multiplied by 10, 50 centimeters squared. I've then just got C to calculate. Now as you can see, my rectangles, they aren't drawn accurately at all here. Okay, but I've labelled them, so that doesn't matter as much. And it's just to help me visualise it so that I'm getting those correct dimensions. So 5 multiplied by 10, 50 centimeters squared. What I then need to do is add all that up. Okay, obviously I've only got very little space left here, so please do forgive for how it's laid out. But that would give me 356 centimeters squared. Okay, job done, silver target hit. I've calculated the surface area of a solid. Now we know that it probably will be a little bit trickier than that in our exam. So I've got this question here. Okay, and obviously we wanted to look at some similarity. So the 2 prisms below are mathematically similar. I want to wrap both of them, but only have 1800 centimeters squared of wrapping paper. Can I wrap them both? So you're probably thinking, why on earth they're talking about wrapping paper in a maths exam? Okay, it's because we need to be able to apply it. Now, similarly to last time, I've got shape A, which is actually what I've just calculated. And again, obviously the same as last time, it doesn't matter if I got that answer wrong before, as long as I'm consistent and I still use it. So I've said from part I, the surface area is 356 centimeters squared. That is for shape A. Now, looking at shape B, I need to calculate my scale factor. It tells me that they're mathematically similar. So I've written it this time. My length scale factor, 18 divided by 2 is 9. I want the area scale factor this time, so I'm going to square that. Okay, so 2 squared, which is 4. So if I want to calculate the surface area of shape B, I don't have to draw all those faces out again. Okay, I don't have to realise that the height is 14 and so on. Okay, in this case, double all of my lengths and work all that out. I can just use that scale factor, okay, that area scale factor. So surface area of B is equal to the surface area of A multiplied by 4. That's because I've just worked that out. Okay, if my length scale factor had been 3, my area scale factor would have been 9, because 3 squared is 9, and I'd have been multiplying it by 9. So my surface area of B is 356 multiplied by 4. My surface area of B is 1,424 centimetres squared. Again, units. So now let's look at the total. So I've got 356 plus 1,424, which is 1,780 centimetres squared. So yes, there is enough wrapping paper. I had 1,800 centimetres squared. I'm only using 1,780 centimetres squared. I've got enough. Okay. Now some of you are thinking, well, actually, that probably wouldn't work. Hence part 3. So it says comment on the validity of your finding. Now my maths was fine there. There wasn't a problem. Okay, so that does work. But actually they're saying, would you be able to do that in the real world? Because what's the point of us being able to calculate this if it doesn't work in the real world? So I said technically there is enough wrapping paper. However, it only allows for 20 centimeters squared of overlapping. So there may not be enough. Now we know when we're wrapping something, we need to overlap, don't we, to cover it. Okay, so make sure it sticks together. Now I've only got 20 centimeters squared. So that was just one reason. That isn't the only reason. I could have also said cutting it out. If there was any wastage whatsoever of that paper, if that went over 20 centimeters squared, I wouldn't have enough. So the chances are I probably wouldn't have enough wrapping paper to wrap them both. Mathematically, yes, I could do it, but I'd have to cut them perfectly, and it'd have to be very, very minimal overlapping, if any. Okay, so again, this would only be like a 1-mark question, but it's just something to think about. It wouldn't be the end of the world if you didn't get that. If you were in the stress of the exam and you were thinking, what's it on about? Why is it saying I've done it wrong? It's not saying that. It's just asking, does it actually work in the real world? Now, something else I just want to point out about this question, because I thought it was quite nice in the case that they said 1,800 centimeters squared. Now, what they could do very, very easily is they could say, for example, 1.8 meters squared, and they would have you convert that. Okay, and then you'd have to look at unit conversions. Now that wouldn't even go to 1,800 centimeters squared. It'd actually be a lot bigger than that. Okay, but they could ask you to convert units as well to then apply that to the question. Now I haven't put that in today because I didn't want to look at that. I just wanted to look at the actual surface area and the similarity in that case. I hope that's been helpful, year 10. Please let me know if you would like to do any more work on surface area and volume. Please do use Maths Watch as well. It is a fantastic resource, and I've sent you a few other websites as well which I think could help.